Hello guys, welcome to uh, DS from scratch. In this particular video, I want to take you through the k-means clustering algorithm. In here, which we will be coding the k-means clustering from scratch. So this is the data which we will be using. We can read that data using pandas read CSV file name. Okay, let's first import the library. pd.read CSV file name. Then let's look at the first five row of the data. Okay, this is our data. Latitude, longitude, housing median age, total no rooms, total bedrooms, population, household median income, median house value, and ocean proximity. Okay, so first let's look at scatter plot of the data. We can use the PLT, the scatter data latitude and longitude. Let's see where all the houses are located. This is the latitude and this is the longitude. So in this problem we will be using only two dimensional of data, latitude and longitude, and based on that we will do our clustering. So we will first we have to decide in how many clusters we are defining the data and which dimensions we are using. So we can take our so we can filter the data only for these two columns. Data dot log, we can use all the rows and only the columns of latitude and longitude. Okay, so this will be our new data which will be performing our clustering on that. Okay, so let's print the data. So this is the data. We have 20,639 or 640 samples with two dimension of latitude and longitude. Okay, so we can add another column of cluster in this data, which will be first we will be assigning 0 for cluster, then later on we can change that cluster. So now all the clusters are 0. So now we can start our algorithm for first with defining how many clusters we want, or in how many regions we want to divide our houses. Okay, so let's see, we want to divide our houses into 5 region. K is equals to 5, and then we can generate random numbers. Okay, how we can generate random numbers? We can put any latitude and longitude as one centroid, or is one centroid, and another latitude and longitude as another centroid. But let's generate random rand integer, generates some random number from inside the data. So random should go up to dt dot shape 0, the number of samples, and the size of the random should be okay, it's 5. Okay, let's print rand how it looks. Okay, these are our 5 index of the random numbers. So now for generating the centroids, random centroids, we can say that centroids is equals to dt dot ilog ran all the columns except -1. Okay, now let's print centroids how it looks. Okay, so now this is our 5 centroids. This is 33.75 and minus 117 latitude and longitude. This is our first centroid. The next 3, 4, and 5 centroids we have selected randomly from the data. Okay, so now we will assign clusters for each centroid. Okay, we can say that the new cluster cluster column will be from range of k, which means 5 clusters. Okay, let's print it. You can see cluster 0, 1, 2, 3, 4 for each centroid. If the data is closer to this centroid, the cluster will be 0. If the data is closer to this centroid, then the cluster will be 1. Similar to that, cluster 2, 3, and 4. Okay, so what we have to do is we have to convert all this data to array, so we can use it, we can work with it easily using NumPy. Okay, C array we can say is equal to np dot array and writes. Okay, and dt array is equals to np dot array, np dot array dt. So now let's look at c array dot shape, dt array dot shape. Okay, yeah, we have successfully converted them to the array which which the centroid arrow has five rows and three columns, and the data set has 20,640 rows and three columns. Okay, so now for the first what we have to do is we have to find the distance from each point to the center. Let's do this for the one point. We can say d is equal to the distance. There is a function in NumPy linear algebra dot norm which calculates the between distance between 2 points. We can say dt, okay, dt array uh, first row all the columns except that cluster column, and c array all the rows or okay, column first centroid all the rows except cluster column. Let's see how the d looks. Okay, so this is the distance from the first point from dt, from this point 37 to the first centroid. Okay, this is the distance from the first point to the first centroid. Now let's do this for the all centroids. Now we want to find the distance from one point to all other centroids. So we can decide that our data is closer to which centroid or to which cluster. Okay, for how many, for C we can see centroids in C array. Okay, let's tap. Okay, so E is equals to in B. Now we can put here. Okay, here we can put C. Okay, now it will find the distance from each, from one point to all other centers. So we can also save it uh, to a list. This will declare an empty list, then we can append it to that list. Now let's see how it looks. Okay, so now we have successfully find the distance from one point to all five other centroids. Okay, so after finding the distance from one point to all other centroids, what we have to do is we have to find the closest point to the closest centroid to that point. What we can do is we can see that the cluster, okay, is equals to the clusters is equals to, okay, distance this dot index, I think, np dot min of test. Okay, okay, we here we have to put index. I think now let's see what will be the result of class. Okay, so class is now 2. As you can see, if you print this, the third row is the minimum distance from the first point to the third centroid. So the class will be row 2, which corresponds to the third row. So after finding the minimum distance or the minimum centroid which is closest to our point, we can assign that to the cluster of the data. So what we can say is dt array, okay, that point, our point was 0, and the cluster column is -1 is equals to class. Okay, so now if we print array, so now we can say that the first row has taken the cluster of 2. Okay, so after this, what we can do is we have done this only for one point. Let's do this for all other points. Okay, how we can do is let's take this all one tab here. You can say that for I in range of dt array dot shape 0, which takes all the number of the samples. Here we can put 0 I instead of the 0. Again in here it will be I. Now let's again print how it looks. Okay, now you can see that it has assigned the clusters for all the data points, but it is only for one iteration. So and our centroids were also chosen like randomly, so these clusters may not be showing very good clustering. So we can see that in scatter plot of SNS, scatter plot dt array, okay, x is equals to dt array all the rows column 0, y is equals to dt array all the rows column 1, and it should be divided based on their clusters. U is equals to dt array, okay, all the rows column 2, and the color of the plot should be maybe spectral. Let's see how it looks. As we can see, it has not clustered the data properly. You can see that this line, this lengthy line, they have only clustered in a particular line, and this line in this line. So it has not clustered the data properly. So what we can do is uh, we can update our centroids. What is the formula for updating the centroids? We can take the mean of each cluster and assign that to our centroids. Okay, for that purpose what we have to do is we have to find the mean value of each cluster. Okay, let's do this here. How to update our centroid values? We have to take the minimum value of each class. Now how we find the minimum value of each class? Let's see that it array from dt array. Again, take the values from the last column, which is our cluster column, which is equals to, like, suppose cluster 2. Okay, it will find all the values which are in that cluster. So what we want to do is we want to only take the values for the uh, first two columns. We don't want to take the cluster column. Now it has given only the latitude and longitude value. So we want to do with this is np dot mean. We want to get the minimum value of that. Axis is equals to 0. Okay, so we will take the minimum value of the each column based on their rows. Let's see. So this is the minimum value, the mean value for the row, and the mean value for the column. So we want to do this for all other the centroids. Okay, so we can see that. Okay, for C in range of k, which is the number of the clusters. Okay, so we can see that cent array cent array okay, uh, row C, all the columns 2 minus 1 is equals to this value. Control C, Control V, and we have to change only this one for each cluster. Okay, for each cluster, and this will update our C value. Okay, so now if we run this code, our centroid will be updated, and then again the updated centroid will go to the next iteration. Okay, when we can update this through using this for loop, and we want to do this many times, so it will till it reaches a good clusters. Okay, so now we can say that for iteration in range of like maximum iteration, how many iterations you want, like suppose we can say 100. Okay, so for each iteration, first it will find this, then it will update the centroid, then again it will go back, again it will update, it will do this 100 times till it will reach a good cluster. Okay, let's run this. Okay, again we have forgotten. It will take some time until it executes this 100 times. Okay, and again we can plot it. Okay guys, so it has executed, so it has 100 times it iterated, and this was our previous plot. Let's plot it in the new plot. Let's see how it has changed the cluster. Okay, so this is our new cluster. You can say that this is way more better cluster than the previous than the previous plot. If we do that for more time, then we can get the better plots and better cluster. So if we increase that 100 to 200 to 300, then we can get the better plots. So thank you so much. Please like the video and subscribe to the channel, so I will keep posting videos like this. I will upload a video on db scan algorithm from scratch also, and also I will try to code most of the machine learning algorithms from scratch, so you will understand that in a better way. Okay, thank you so much.